Hi, I'm Aaron. Today, we're at SMP in Greenville, South Carolina, where we're going to learn everything that goes into designing and manufacturing standard fuel injectors. Now, this facility is entirely vertically integrated, which means the components that are used inside of the injectors are also manufactured here. That helps ensure quality throughout the entire manufacturing process. Let's head over to the design center to see where it all starts. Now, before any part can go into production, it has to be designed first. And that's what happens here. A team of design engineers are creating the next generation of applications, testing them, making sure they're correct before they go to production. The very first step in manufacturing is receiving the raw materials. Here, you'll see multiple diameters of stainless steel rods that come from American steel suppliers. Now, the reason there's so many different sizes is because they're used for different components of the fuel injector. Here is where incoming components are inspected before they're sent to the production floor. Now, this facility does manufacture just about everything in-house. But there are a few components, things like ball bearings and bobbins, that are manufactured in other US facilities. Now, let's go take a walk to the production floor. To control quality on many of the stainless steel components used inside of the injector, metal rods are cut using the latest machinery. This is where the armature is assembled. The stainless steel ball bearing is laser welded onto the armature. Before they're heat treated, they're cleaned to make sure they're free of any contaminants. Many of the components used inside of the injector are heat treated to improve strength and durability. This facility is able to heat treat all of their own components, and each heat-treated component is then cleaned before it makes its way back to the production floor. High-grade copper wire is wound onto the bobbin using the latest state-of-the-art machinery. Again, like many other steps, this is done in-house to control quality. Of course, every single component used in the fuel injector matters, but this small component is really the most critical. It's called the metering disc. The number of holes, their size, and their arrangement determine the spray pattern of an injector, and this is crucial to fuel atomization. Here, lasers are cutting precise holes onto the disc to ensure accuracy and consistency. Now, it's time for final assembly, which is done inside of a pressurized clean room. Before I go in, I need to put on a cap, shoe covers, and lab coat to prevent contamination. Inside here is where it really starts to come together. First, the hydraulic tube is assembled. This is done using a spring, the armature assembly, valve seat, and the metering disc. Each assembly is individually calibrated, but before it can be calibrated, it is run in on this machine. Then it's calibrated to application-specific parameters. Next, that injector assembly is welded to the inlet tube. And then the electrical terminal is welded to that assembly. Although it may not look like it, at this stage, we have a functioning fuel injector. The injector is then tested before it's sent on to overmolding. Now, it's time for the overmold. Here, a technician oversees its application, and what comes out of the machine looks a lot like the final product. The next step is end-of-line testing. This is where each injector is tested for coil resistance, dielectric resistance, and any leaks. Now, it's time to install the high-temperature Viton seal. These are application-specific and really help to ensure a long-lasting positive seal, preventing leaks. The injector is then placed into a bag and sealed to prevent any contamination before it can be installed on the vehicle. This precision manufactured injector is now ready to be placed into the standard box. From research and development through the entire manufacturing process to packaging, that's how it's done. Thanks for following along.